This is the #1 final review for Algebra 2 first semester. So the first thing we're going to work on is just reminding you how to go about solving equations with fractions. A fractional coefficient, -3/4 is a fractional coefficient. So I'll take you through the steps, and then you'll do a couple on your own and check your answers. We're going to subtract 4 first. We're left with -3/4 x equaling -6. Now, you need to get rid of this fraction, you need to multiply by the reciprocal, which is going to be -4/3, because you want it to be positive x. So a negative times a negative is a positive x, or positive 1x. You multiply the other side by a -4/3. Whatever you do to one side, you do to the other. And if you want, it may be easier for you to put the -6 over 1. -6 times -4 is +24. 1 times 3 is 3. Then you just divide it. 24 divided by 3 is 8. Sometimes your fractions will simplify completely. Sometimes they will not. So I'm going to give you 2 problems. I want you to pause the recorder, try them on your own, and then I want you to turn it back on, check your work, and figure out fix anything that you missed. Okay, your 2 problems are #1, 2/3 m plus 5 equals 11, and #2, -6 equals -4/5 x plus 4. Remember, you will be turning this into me, so you need to show all your work, be neat, so that I can see what it is you have done. All right, for #1, 2/3 m plus 5 equals 11. You subtract 5 from both sides. You end up with 2/3 m equaling 6. You multiply both sides by the reciprocal of 2/3, which is 3/2, or 3/2. 2/3 times 3/2 is 1m, which can be just written as m. And 3/2 times 6, if you put a 1 under the 6, you get 18/2, 18/2. That's 18 divided by 2, which is 9. #2 is -6 equals -4/5 x plus 4. Doesn't matter that you don't have the variable on the left, so you end up subtracting 4 from both sides. So it is -10 equals -4/5 x. You want to get the x isolated, so you're going to multiply -4/5 by its reciprocal to get 1x, or x, which is -5/4. So negative times a negative is a positive. Multiply the left side, or the -10, by -5/4. You may want to put a 1 underneath the 10. It gives you +50/4. Negative times a negative is a positive. And 50/4 can be simplified. 2 divides into both 50 and 4, gives you 25/2. Please don't make it 13 1/2, or 13.5, just leave it as 25/2. Okay, the next part of the review is to determine if the relation is a function and explain why. You need to also write the domain and range. And remember, the definition for a function is, so a function, if a relation is a function, for every output, for every input, that's your x value, there will be exactly, and that was a key word there, exactly one output. And that's your y value. For every x, there's going to be exactly one y. That is the formal definition of a function. We're going to use the vertical line test to help us as well. Okay, so the first thing is let's go ahead and write the domain and the range. So domain, you don't rewrite any of them, and you can put them in order if you want, but it's not necessary. So we've got 2 as an x value. Domain are all this set of x values. -4, -3. Don't write 2 a second time. For the range, those are all the output, or y values. And so we've got 5, 3, 5, -1. We didn't write the 5 a second time. All right, so we have domain and range, and now determining whether it's a function. I'm going to draw a rough sketch of a coordinate graph. So 2, 5 would be about here. -4, 3 would be about here. -3, 5 out here. and 2, it's 2, 5, 2, negative 1. Okay, so if you do the vertical line test, that point right there, the negative 4, 3, only has 1 point on it, so it passes the vertical line test. For the negative 3, 5, there's only 1 point on the vertical line, so it passes the vertical line test. But when we get here, we can see that there are going to be 2 points on that vertical line. I meant to go through the point. Let's try that again. You can see that there are 2 points on that line, so it fails the vertical line test because for the input value 2, you can see you have some x's that are the same. It has an output of both 5 and negative 1. So it does not pass the vertical line test because for every input there is more than one output. Okay, so not a function. For every output, for every input, there is more than one output. You could put it fails the vertical line test, comma, so it fails the vertical line test. And the one that, where you're seeing it, it was great here and here, but where you're seeing it is 2, the x value 2 has 2, not exactly 1, 2 outputs, 5 and negative 1. Again, that's more than we need, but it helps you understand. You may pick parts of this, but you should always use the definition, part of the definition in your answer. So the definition is for every input x, there will be exactly one output y. Now you're going to do a couple of problems, and then you'll shut the recorder off, and then you'll check them. So you'll write them down, shut the recorder off, do them, and then you'll check them. Okay, here are problems 3 and 4. Go ahead and write them down on your paper. Write the domain and range for both, and then determine whether it is a function or not. I'm going to suggest that you do the vertical line test on just a rough graph, because I think you'll be more accurate that way. Once you're done, go ahead and turn the recording back on and check your answers. All right, if you look at number 3, its domain, its input values are 1, 2, 3, and 4. Its range is 1 and 2. The ordered pairs that it's showing you are 1, 2, 2, 2, 3, 1, 4, 1. It is a function because when you look at your little tiny, I just made a little rough sketch here. You have 1, 2, and then you have 2, 2. Those all pass the vertical line test. There's only 1 point on each of the vertical lines. And then when you go to 3, 1, and 4, 1, so you go out 3, 1, there's only 1 point on that vertical line, and 4, 1, there's still only 1 point. So for every input, there is exactly one output. For every x, there's one y. And another way you could look at it too is the y coordinates never repeat. So for the the x coordinates never repeat. So 1, 2, 3, and 4. So there's never a repeat or a duplication in the x coordinates. Okay, let's go to number 4. It's a little different table, and it's an input-output table. The ordered pairs are 1, 1, 2, 2, 1, 3, and 2, 4. The inputs are 1, 2, 1, 2. We only write 1 and 2 for the domain. The input values are 1, 2, 3, 4, so the range is 1, 2, 3, 4. And it is not a function because for every input there is more than one output. So if you look at the quick graph, 1, 1, and 2, 1, 1, and 2, 2, and then 1, 3, and 2, 4, you can see there are 2 points on the first vertical line, and there are 2 points on the second vertical line. So it actually fails the vertical line test more than one time. And there is a repeat, 2 1s, 2 2s in the x values. Okay, now we're going to move on to the next subject. Okay, we're going to be working on graphing systems of linear equations. So this is chapter 3. You have two equations, y equals 2x plus 3 and y equals negative 3x plus 8. Graphing is a great way to show how systems work. Basically, when you have two lines, you graph them, and the point of intersection is the solution for those lines. So we'll graph this one. Your y-intercept is 3. We're going to graph in two different colors. So the m equals 2, the b equals 3. We're going to go up 2, it's got positive slope, over 1, up 2, over 1. And then we'll connect those lines. Let's go down 2, over 1. There's our line right there. I'll get a different color. This is negative 3x plus 8, so we go up to 8. Plot a point. We're going to go down 3 and over 1. There's our point of intersection. We'll go down 3 and over 1. We're going to connect our points with a line. You'll use a straight edge when you do yours. Okay, so the point of intersection is 1, 5. Another way to solve a linear system or a system of linear equations is using substitution. So we have two different methods that we are using here. The first method being graphing the system of linear equations to find the solution 1, 5. The solution is just the point of intersection. And the second method being, what we're going to do right now, is going to be substitution. So you have y equals 2x plus 3, y equals negative 3x plus 8. You can go ahead and take this right here and substitute it into that y right there. So then you're going to get negative 3x plus 8 equals 2x plus 3. Then you'll go ahead and you will collect your variables, try to keep them positive. So we're going to add 3x to both sides. And we're going to have 8 equaling 5x plus 3. We subtract 3 from both sides, getting some equation practice here. 8 and negative 3 is going to be 5, and that's going to equal 5x. We divide both sides by 5, and x, or 1, equals x. That's our x value. So we're going to have an ordered pair that's going to be 1. Now we need to find y. You can plug into either of the equations. I'm going to go ahead and plug in the 1 to the first one. So y equals 2 times, we're going into 2 times x, 2 times 1 plus 3. You're just substituting. Y equals 2 plus 3, and y equals 5. Okay, so those are intermediate answers, with our final answer being the point of intersection, which is 1, 5. Okay, number 6 and 7, you're going to graph and then use substitution. Go ahead and write those down. And then number 7, you're also going to graph and then use substitution. You should come up with the exact same answers for both. Again, once you're finished, turn on the recording and check your answer. All right, on number 6, to graph 3x plus 1, you find that m is 3 and b is 1. And for y equals negative x minus 3, m is negative 1, b is negative 3. So you go ahead and plot your 1, go up 3, over 1, down 3, back 1. Then you go and plot your y equals negative x minus 3, so negative 3. So is your y-intercept. You go up 1, back to the left 1, up 1, back to the left 1. You see right now that the point of intersection is negative 1, negative 2. For substitution, you substitute the negative x minus 3 into the y position. Negative x minus 3 equals 3x plus 1. You collect the variables on one side. Try to keep them positive, so you add x to both sides. Negative 3 equals 4x plus 1. Subtract 1 from both sides. Negative 4 equals 4x. Divide by 4 on both sides. X equals negative 1. You substitute that into one of the equations. I chose 3x plus 1, so y equals 3 times negative 1 plus 1. Y equals negative 3 plus 1. Y equals negative 2. So your ordered pair is x is negative 1, y is negative 2, negative 1, negative 2. It matches up with your graph exactly. Graphing y equals 1, this is number 7, y equals 1/4 x minus 2. Plot at negative 2, go up 1, 4 to the right, go back to the vertex, go back to the y-intercept, down 1, 4 to the left. Then you graph y equals negative 2x plus 7. 7 is your y-intercept, that's your b. You go down 2 over 1, down 2 over 1. I just kept doing that until I intersected with the red line at 4, negative 1 for the graph. For substitution, you're going to substitute negative 2x plus 7 into the y position. Negative 2x plus 7 equals 1/4 x minus 2. You're going to add 2x to both sides, which equals 7, gives you 7 equals 2 1/4 x minus